First, let me introduce myself. I'm Roger Gilbert. I'm the publisher of Perrindale Publishers. We publish the magazine Milling and Grain, which is in 6 languages monthly, International Aquafeed, and International Pet Food. So we are global in our reach, and it's very important that we connect with readers throughout the world, especially in Milling and Grain, which was first published in 1891. It's over 130 years old and still in print. And my job as a publisher is to see that it remains in print through this crisis of the digital era. So please avail yourself of a copy out there. We're offering free subscriptions, and which reminds me also, if anybody's driven here today, don't forget to get your invitation stamped out here. They give you a free car park. But today we're here to talk about flour milling maximised. This is a concept that Victam has developed through Grappas over the years, and I'm pleased to say it's culminated in this focus on flour milling. And there's also obviously a feed milling maximised, but this is for flour millers. And the industry needs greater representation, as we were discussing earlier, across the milling sector. We can't be pigeonholed into one product. We should be aware of what is happening globally in all sorts of milling. And this is an opportunity for the flour millers to participate at a venue for feed millers. Okay, today we have 3 keynote speakers. They will have a longer duration of 20 minutes, and we have 6 industry speakers who have a duration of 10 minutes each. And they will focus on sustainability. We have 3 speakers there, environment, 2 speakers, and on energy. Things that we have to take into account given the way the globe or the international community expects us to look at controlling our CO2 footprint and reducing or improving the efficiency of what we do. And there's many aspects to food production that we have to contend with, including costs, etc. So it's not just about CO2 moderation, it's also about other aspects. And so we're covering those today, and we're trying to have as broad a spectrum as possible. I'm pleased to say that in the audience and as keynote speakers, we have representatives from 2 of the larger flour milling manufacturers on the planet. In fact, I believe we have the representation from the largest flour miller on the platform on the planet, and he will be speaking later in the program from Woodley. So let me first of all ask my colleague Sebas Vienda to come up here. He's the general manager of Victam. We are jointly promoting Grappas. And I'd like Sebas to say a few words of introduction. Welcome, Sebas.
Thank you, Roger. Good morning, all of you. Indeed, it's a little bit early today, so probably people drop in during the presentation, so we let them come. But first of all, I would say, Roger, thank you very much for doing this again together. Perrindale and Victam, I think, work together since a long time. More and more. Every time it's more intense. Especially this one, I'm very happy that we are focusing on this flour milling industry. Flour milling industry is winning strength at the exhibition. We see more and more. For example, in Brazil, we work together with GIPS, the Grain Elevating Association, as we see storage is an important thing. Elevating is an important thing. So we are happy that we're here. We are very happy with big flour mills from Indonesia and China here in the room to give a nice presentation. Hopefully everybody has time to come to the exhibition after this event so that you can see the technology and the new innovations at the event. I keep it short as we have a lot of speakers and a lot of time, so hope you will enjoy. Thank you, Berno.
Thank you very much, Sebas. Thank you. Okay, so without further ado, let's get on with our program. And we have our first speaker is Adi Watano. Witano, and he is from Bogasari of Indonesia. And as I said, we have two of the world's larger flour mill manufacturers in the room, and Adi is certainly one of them. And it's a great pleasure to welcome you here today, Adi. I mean, it's fantastic that we have you and Woodley in the room, and we are all looking forward to your presentation. Please. Just before just before we move on, there's a QR code that will pop up occasionally, which will give you access to our Milling and Grain magazine. I think you just click it forward. There we go. Can I first say that Adderley has a background in wheat milling, is currently in charge of operations, and is the operational vice president for Bogasari division of PT Indo Success Muku. Could you pronounce that, Muku?
Success Makmur.
Success Muku.
Success Makmur, yeah.
Surabaya in Indonesia. Yeah.
Thank you. Thank you. Good morning, ladies and gentlemen. It's great to see you all here, and I would like first to thanks to Victam and Parendel as the organizer of this event for inviting me here today. And I am very honored to have the opportunity to address the presentation to you this morning. Yeah, my name is Adi Witono. You just can call me Adi, a simple name, Adi. Currently, I work as a operation vice president in Bogasari, in Surabaya plant. We are a division of Indofood, Sukses Makmur, in Indonesia. This morning, I would like to present about to address about what Bogasari has been doing related to the contribution to sustainability of our environment. Maybe our country is still different from yours, yeah. But at least Indonesia is going forward to go to the more concern about the environment in the future. Yeah, Indofood, I think, is a well-known consumer good in Indonesia, manufactured in Indonesia, especially with its product like instant noodle, Indomie, with brand Indomie. This is a quite worldwide producer that you can find mostly in the, I think we already export in 80 countries with the instant noodle name with the Indomie. We have Indofood have a vision to become a total food solution company, and the mission is to provide a sustainability solution for the food needs, to continuously improve our people, processes, and technologies, and to contribute to the welfare of the society and environment in the sustainable manner. To continuously improve the stakeholder value, and also the value that we adopt is discipline, integrity, respect, excellence, and innovation. Indofood actually has progressively transformed into the total food solution company with operation all in the stages of food manufacturing, start from the production of raw materials and their processing to consumer good in the market. For example, like Bogasari itself, Bogasari Group is we are a raw material processors. We produce wheat flour milling to become a flour. And we have also our division. Another division is a consumer branded product that's manufacture the product that's going to the market, to the consumer, like a noodle division, dairy division, snack food division, food seasoning, nutrition and special food, beverage division. This is a part of the consumer branded product. And the agribusiness is mostly is a palm oil. We have a plantation of the palm tree, and then we produce to become the edible oil and fats division there. We also have our own distribution channel, the distribution group that distribute our product in the markets, especially in Indonesia. Our sustainability practices are based on the 3 pillars that represent all the 3 bottom line: people, planets, and profits. Our sustainability strategies are founded on these 3 pillars and serve as the basis of our program implementation required to achieve our vision. The first pillar is resilience in delivering food for all, like including the product safety, quality, and halal, because halal is very important in Indonesia because the majority is a Muslim. And the nutritional value, we concern about the nutrition of our product, responsible marketing and communication, sustainable of responsible sourcing, socio-economic inclusion, governance and ethics, resilience and innovation. And then we also concern about the environment stewardships, including like our concern about the climate change and GHG, the greenhouse gas emissions, energy management, water management, packaging and waste management, and also biodiversity. And also we concern about the people, stronger together with our people and community. We concern about our employee health, safety, and well-being, labor practices, and people development, and also community development. Bogasari, as the biggest flour mill in Indonesia, we have actually 4 plants in Indonesia with a total capacity about 21,000 tons wheat mill a day. Maybe we are the biggest flour mill in Indonesia in one location, but here we also have Wudeli that have more capacity because than Bogasari. And when our production started in 1970, I think we used the calico bags as our packaging materials. And around 80s, we start to transform our packaging material using the PP bag because this is more affordable for our consumer until now. But we understand, we aware that for the future, to achieving the sustainable environment, Bogasari keep trying to reduce the PP bag usage by using implement several efforts. Like we use the reusable jumbo packaging to some of our customers, and we try also to encourage our consumer to change their packaging material, their system from the 25 kg PP bag become a bulk delivery system, and also like using the normal container. So we use the technology, the tilting equipment to tilt the normal container as a container for the pallets product to some of our customer. With this effort, at least we can reduce about 1,500 tons of packaging material waste annually. Maybe small thing that we use, we have done also in the office works is to reduce the paper usage by changing some activities in the paperless way, like employee permits and safety working permit. We use everything in the digital manner. It's also like a training program, the training activities. We do it all in the digital way, so we can reduce the paper usage. This is a quite sense because of at least Bogasari employed more than 3,000 employees. So this something that helped to reduce also the paper usage. Bogasari is also carries out several activities related to the domestic waste we produce, like we sorting the trash based on the type of the waste, And then we also process the leaf waste, the leaf that fall from the trees, become a compost, and we use it as a natural fertilizer for our garden around the factories. And one of our plants is also can reduce about 850 tons annually our domestic waste that we collaborate with the third party to use our waste as a fuel replacement, fuel substitution. We also collaborate with the waste bank. We call it a bank sampah in Indonesia. Sampah is waste. So that's an NGO, the non-governmental organization that works, collect all the waste, and they try to separate all the plastic waste, and they can, this is for recycle, and they get the funds, and the resulting fund was used for the community activities around the company site. Bogasari is also established a partnership with the community groups to rehabilitate the mangrove ecosystem near its jetty, to revitalize and maintain the water surface. As we know, mangrove has many benefits, such as absorbing carbon dioxide, bearing fruit, live with a high protein content, preventing coastal erosion, and serving as a habitat for the variety of fauna. Bogasari has already managed this mangrove, start from the nursery till their planting. And until now, from the 2018, we already prepare about 5,000 ready to plant mangrove, and about 2,300 we have already planted in the coastal area near our jetty. Another small thing that we also do, as we are aware that water is one of the main resources that we use in the flour milling process, we concern about how to conserve the water. So the small thing that we use here, we make a biopores in the soil. This is to help increase the water penetration into the ground, so the rainwater can easily penetrate into the ground. And we also doing some rain harvesting. We collect the rainwater from the top of our storage, and we collect them and use it as a domestic usage. And thanks to that, our two big plants in Jakarta and Surabaya, our site is close to the port because we have our own jetty for our incoming raw material. So we can invest and also build the SWRO. This is our seawater reverse osmosis that we produce the fresh water from the seawater. And we have our capacity is 1,750 cubic meters daily, and at least we can use about 250,000 cubic meters annually, and this is about 50% of our usage for production and non-production usage. We still use the water from the local provider because we try to maintain the relation with the local provider as well. In Indonesia, government is also encourage us, especially the big industry, to improve their efficiency and productivity by upgrading the automation level of their process to the program INDI 4.0. This is the program that developed by the government, Industrial Ministry of Indonesia, that's empowering us through the socialization, guidance, and mentoring of the big industry. And Bogasari is also doing by applying the more automated machineries and implementation of digital automation system. We employed some high efficiency motor that equipped also with the smart sensor that able to anticipate the downtimes, then increase the service level of the motors. And in the end, also increase the efficiency and productivity. In the production side, especially for the process monitoring purposes, we have already done all the resources integration to one real-time monitoring system. We use like a SCADA to collect all the information from the all resources that we use, such as electricity, water, steam, and compressed air to production operation. So we can monitor in the real-time basis all the resources that we use to produce our flour here. By monitoring in the real-time basis, we can take immediate action if there is something happening in the production line that will affect the resources usage inefficiently. This is what helps us to be able to run our production more efficient and more productive. At the same time, we use the collected data to measure our production result, performance, and the highlights of the production, as well as for the dashboard to our management report. At the end, the reduction of all resources usage, our company can also be able to contribute to conduct the sustainability to our environment and reduce the greenhouse gas emission, and keeping the company commitment that in line with the government regulation that industry, all the industry that use 4,000 tons oil equivalent must be doing the energy conservation. And we also implement the ISO 15000 that helps us also to manage our resources, especially in the energy usage manner. Throughout the Indo-Food Group, throughout the Indo-Food Group, one of our plants also installed about 4,600 square meter of the solar panels on the rooftop of the warehouse. It helps us to do the emission reduction of over 940,000 kilograms of CO2 equivalent, and now is providing also the more than 1.1 million kilowatt hours of the clean energy every year. And we know that the potential of the benefit, financial benefit of implementation. In the future, we also want to install the solar panel, solar energy for our other plant. With all the effort that has been doing by our company, the application of the green industry concept that requires a continuous improvement-oriented approach to efficient through economic measures across a variety of factors like material, water, energy, use of alternative energy, use of the safe materials for humans and environment, and the use of the low carbon technology that we implement to our industry. In 2022, Bogasari received a level 5 of the Green Industry Award from our Ministry of Industry for its innovation in preserving the environment. This is the third year in a row which Bogasari has obtained the highest level of the green industry achievement by its effort to conduct all the sustainability, the effort to do the energy conservation. Bogasari also received the most innovative terminals to support the green port because of our effort, as well as the best terminal and environment management facilities, as well as the terminal with a zero accident achievement from the port authority in Jakarta. In the same years, Bogasari also became the first flour mill in the world to have been awarded the International Energy Management Leadership Award of Excellence and proudly received the formal recognition of the awards during the Global Energy Action Forum in September 2022 in Pittsburgh, USA. This is at the joint convening of the 13 Clean Energy Ministerial and 7 Mission Innovation Ministerial for the effort and the achievement related to the energy efficiency. The award was intended as a showcase the organization that has demonstrated the leading sustainability practices and to share the ISO 15000 energy management success. Within the 5 years of implementation of the ISO 15000 that help us to manage our energy usage, our company improved its energy performance by 23% and reduced emission by over 56 million kilogram of CO2 equivalent and realized the energy cost saving for about over the 4.7 million of USD in terms of the our reduction in the energy usage. I think this is all that Bogasari has been doing toward the sustainability environment, and we as a company in Indonesia, we commit to improve our activities for a better future. Thank you very much. Thank you. Thank you.
Thank you. Thank you very, very much. I think the thing that resonates with me is even the small things are taken care of. Besides the big savings, the small things, the groundwater, the leaf composting. I think sustainability is not just about the big issues, and it's good to see that a company is taking that much care. Now, under the topic of sustainability, we have two of our exhibitors from the floor downstairs who are going to address us around sustainability. And the first one is David Balagar of Balagar Rolls. He's very familiar to everybody in the feed milling industry as he is in the flour milling industry. David, you're going to talk to us about Cronus roll and one and only indefinite chilled roll. Thank you very much.
Yes, sir. Roger, what is my lesson? Okay. Well, today for me it's really an honor to talk in front of so high-level representatives of the flour milling industry in the world. We have Budeli, we have Bogasari, the biggest flour milling processors in the world. From my understanding, sorry? Okay, yeah. I was saying that for me it's really an honor to talk today in front of the highest flour milling processors representatives of the world. We have Budeli, we have Bogasari, we have other milling processors that really, sincerely, I believe that you have a huge responsibility because you are actually feeding the world, you know. So the responsibility behind this is huge. For me, for my company, for a small company like Balagar Rolls, and for other companies that are related to the milling, our responsibility is also to provide you with the latest and more innovative tools in order to make your processes more efficient, safer, more profitable, more sustainable. So we understand that your responsibility as the feeders of the world is huge, and we also understand that our responsibility as suppliers is also important because we need to provide you with the best possible tools according to the evolution of our companies. That's why Balagar Rolls Company, I give you a brief introduction about our company. Our company was created in 1916, and we've been specialized in manufacturing rolls from the beginning of our history. We maintain the philosophy of a family company. I belong to the fourth generation of the company, and continues every year. We are investing 15% of our net income in research and development of new products, new materials, new casting recipes, new rolls that will make the work more efficient to the mills. Today, I'm introducing what we believe it really is a revolution in flour milling. Is a new roll, a new reduction roll that we call Kronos. This reduction roll actually is the only roll in the world that is being casted by only a single material, one material only. So we call it indefinite chill. We are used to see rolls with a B-metal structure, with a hard layer of white iron, an inner layer of gray iron, but this is the only roll in the world who is indefinite chill. This Kronos, this Kronos is the result of a research and development of Balaguer Rolls company for 6 years, and it has been tested in many mills around the world. The main features of the roll, of this Kronos roll, is, as I said before, is indefinite chill, single pour material. The hardness of this reduction roll is softer, is lower than other smooth rolls. You can think that maybe because of this lower hardness, the wear of the roll will be faster. We can say today that absolutely not. We found after many trials, we found the ideal hardness for a smooth roll to be more efficient. We all know that smooth reduction rolls, the softer are the better. But of course there is a limit. You cannot manufacture a roll of 250 Brinell, of 300 Brinell, because that roll will wear out dramatically in a couple of weeks. So it's our job, it's our duty from the point of view of a roll manufacturer to find the right harness, the ideal harness for a smooth reduction roll, and we found it this time with this Kronos. Because of this ideal harness, this roll still has high wear resistance, and because of the special structure of this single pour material, the roughness of the roll will always be in the surface of the roll. So this means that these smooth rolls will always be rough. I will explain further about this point later on. But why we should choose from now on Kronos rolls on reduction milling passage? And the main advantage of this Kronos roll is that the rolls will run at lower temperature than other smooth rolls. You can optimize your start damage. You can have energy savings while running Kronos rolls. You can maintain the roughness in the surface of the roll forever, as long as you don't need to do the camber of the rolls. And you increase the sustainability of your mill, because at the end of the day, you will avoid so many stops and startups of the machine, because this Kronos roll will stay longer in your mills. But we can go point by point, feature by feature about this Kronos roll. When we say that we increased the extraction rate using Kronos roll, what we mean is that in those roller mills where we have installed the Kronos, the average of optimum flour passing through that specific roller mill is higher than using standard smooth rolls. When we say that the Kronos roll maintains the matte finish, we are saying that the roughness of these reduction rolls will be maintained forever, because the material is rough itself. When we talk about smooth reduction rolls, we know that the surface of the roll must be rough in between RA 2.5, 3.5, right? Some mills require more roughness, 4.5, 5.5. That's fine. But with the rolls that we are used to use in the past, you need to do the resandblasted because the surface of the roll during grinding will become like a mirror, so you need to resandblast the roll. This material, this Kronos, because of the structure of the material, because of the porosity itself of this material, is rough by itself, and during operation will be even rougher. So at the end of the day, the only reason why you need to dismantle this roll and take it to a grinder is because you want to do the taper of the rolls. Okay? Probably the main feature of this Kronos roll is the temperature of the roll. We, after the different trials that we have done with Kronos rolls, we discovered that Kronos rolls will grind at lower temperature than the standard reduction rolls that we normally were used to use in the past. That means that the roll temperature will be lower, between 2 degrees to 6 degrees lower, and so the flour temperature will be lower. That means that, I'm sure that you all know how important it is to keep the flour temperature to avoid hot flour, right? The effect of hot flour can be really negative for the quality of the protein, you know. So grinding with a lower temperature, achieving a lower flour temperature is something that is a huge achievement from the point of view of the rolls manufacturing. Why we say that using Kronos, we are also increasing the sustainability of your mills, because basically you will maintain the rolls in the machine for a longer time. You don't need to shut down the machine so many times. You to start up the machine again so often as you were used to do with the former reduction rolls. Talking about energy savings, according to the trials, according to the tests that we did in several mills, we found out that if you want to maintain the same production level, you don't need to press the Kronos rolls as much as you are actually pressing your existing reduction rolls. So that means that at the end of the day, the mill will have energy savings because you can run the rolls without high pressure. When we talk about optimum start damage, another feature of using Kronos, this is related to the less pressure, pressure between the rolls because of the rough structure of this new material. There is a less rubbing between the rolls, and at the end of the day, there is a less pressure. So at the end of the day, you are able to optimize your start damage. One of the tests, one of the trials that we did at the end of our 6-year investigation about Kronos was performed in one flour mill in Spain, in a 750 tons flour mill. For you, probably, Mr. Adi, Mr. Raimon, 750 tons will not be a big mill, but for Spain, it's a huge mill, you know. So we did a trial of Kronos on a soft wheat mill. The name is Harinera Villafranquina from Spain. And we installed a pair of Kronos rolls in C1 passage, another pair in C2 passage in the same machine with one pair of standard smooth reduction rolls in each machine. At the end of the trial, that was about the investigation took place, the trial about 1 year, about 1 year long. The mill came with the figures that in those 2 roller mills, they were able to have a 5% energy saving, a running roll temperature of 6.5 degrees less, 2.5 degrees less of flour temperature, and 8.7 more flour production in these 2 machines. When we talk about, when I say 8.7 more flour obtained in these 2 roller mills, I refer specifically in this mill, in C1 and C2, the flour, they consider actually good flour below 180 micron. So in these 2 machines, below 180 micron, they obtain 8.7 more flour using Kronos roll than using K01 rolls that actually, for your information, K01 is the standard reduction rolls that we are all used to use in the past, where the hardness is between 520, 570 Brinell. The Kronos, the hardness is much lower, is in between 350 and 430 Brinell. So, of course, milling, as you will know, is not the same in Europe compared to Mexico, compared to China, compared to Indonesia, compared to Saudi Arabia. But at the end of the day, what is the same for any flour mill is the advantage of having materials that will not get hot, materials that will not expand unevenly, materials that will help you to reduce the energy cost, and materials that will help you to maintain the rolls in the machines for longer time. And this is actually the main feature and the main target of our Kronos roll behind our investigations. So this is all about the Kronos. If you need any further information, Balaguer rolls, we are downstairs in our booth. So I think that's all. Thank you very much, everyone.
Thank you very much, David. Fascinating subject, rolls. We take them for granted. I carry a miniature one round on my key ring that you gave me, David, a long time ago. And I think rolls are essential to the foundation of our industry, and it's great to see that you're making such an advance for the industry. Talking of sustainability, I'd also now like to look at sensors. And with that in mind, we've invited Hydronics, Neil Cass, to speak to us on the importance of moisture control and measurement throughout the milling process, and the innovations and sustainability that go along with that. But Neil, the floor is yours.
Thank you. Good morning, everyone. I don't know whether to use this one or that one. So just to give a bit of a background to Hydronics, my name is Neil Cass from the UK, and Hydronics is a family-owned company which has been in existence for about 42 years now, based in the southeast of England, that developed and manufactures and markets sensors for measuring moisture in milling or in production processes. So why do we suggest to measure moisture? So grain is a natural product, and so the moisture in the bonk material varies from a number of different sources, including the different growing conditions, the final harvest conditions that you get in the fields from the farms, and the cutting and threshing, and then the storage itself, so how the material's being stored in the production plants. This is critical for processing because obviously the moisture tends to be the critical factor in a lot of different production stages, with the mill affecting machinery performance, material elasticity and plasticity and malleability, and the final product quality, where it's important to have the correct moisture level so that you have, otherwise if the material's too dry, it makes it difficult to use, and if it's too wet, you can then be prone to spoilage in the storage, or it causes problems with grinding and milling. Finally, by knowing and subsequently controlling the water content during the processing, it's possible to improve the efficiencies of the plant and to use that to reduce the carbon footprint and to save money in the production processes. So just to summarize, so repeatable moisture control can give you higher yield from your raw materials, higher quality in your products, higher profitability from those materials and products, whilst reducing waste products, so products from bad batches and problems in the processes, reducing the energy consumption in the production processes, and then also reducing the carbon footprint. So where in the production processes can we measure moisture? And I apologize, this isn't quite a flour milling process, but it sort of gives an idea of the different areas that we can measure. So the first step is measuring in the intake and reception areas, the subsequent transfers to storage areas, in storage itself, and in any drying processes that are done on the raw materials coming in. So this allows the materials to be managed as obviously temperature and moisture content, as well as the natural humidity in the environment, are key factors in things like mycotoxin contamination and growth, which can lead to spoilage of the raw materials and short storage lives. It can also cause hotspots in the storage facilities, sometimes even leading to more drastic problems like fires. Obviously, if there's a drying stage in the process, then it's important to measure and control that drying process to get the moisture correct, to prevent any damage to the material as well through over-drying, and obviously wasting energy from that over-drying, leading to extra cost and environmental impacts. Then moving on, in the grinding stage, obviously it's important to get the material moisture correct, to get the, and this is normally done using water condition or tempering and conditioning steps, to get the correct moisture before the grinding to get the efficient mill performance. Moisture affects the elasticity of the material, and this in turn affects things like particle sizes, causes problems with dust and cracking, and increases the energy used by the mill itself. In mixing processes, if you're using the flour to then make any extra materials like pasta or other doughs, it's important to get the moisture correct in both during the actual weighing of the raw materials, because the weight of the water affects the weight of the dry materials going into the mix, and also in the mixer itself to get the final mixture water content correct for the next parts of the process, which then would generally go on to some sort of extrusion process, where obviously during extruding it's important to have the correct moisture, so otherwise you'll get extruded product which is either poorly shaped or doesn't hold its shape, is stickier and can cause more friction in the extruder, causing higher energy and possibly even leading to blockages and problems with the extruder. If the moisture is too low, then obviously it can create dusty material that then causes problems in any next steps, like any drying or other processes coming after. Then in the final packaging and bagging areas, it's important to have it as a final product quality check. So how do we measure moisture? So traditionally what's happened is people tend to measure moisture by taking samples from their process, taking it to the lab, running a loss of weight or an IR system on that sample and using that product. However, using an online measurement allows you to react quickly to changes in the moisture and get a full knowledge of the moisture in the whole process. This can also give a much better accurate representation of the moisture during that material movement, not just at a single point. To demonstrate this, if we take these 3 points on this varying graph on the right-hand side, obviously you can see that these 3 points we've taken samples at are at the high spots in the material moisture flow. And if you averaged those 3 points, you would get an average of around 24% moisture. If we actually take an average of the whole of that batch, you get more of a 22% number, which would obviously be a 2% error. So different ways of measuring moisture. There are a number of different technologies, so I'll just run through them just to explain a bit about them. The first is NIR, or infrared. It's a very good technology. It tends to be a little high in cost and also has a lot of ongoing maintenance. It can only give a surface reading because of the way the measurement works, and tends to be affected by changes in the material color and also any dust or steam that's coming off the material at the same time. However, this can be offset against the fact that the IR measurement can give a lot of information, for example, protein and fat contents, and so is a very good product for using if those are needed. Older technologies like resistive, capacitive, and older microwave analog technologies use an RF signal to react with the water at a lower frequency, and that determines one of the electrical properties of the material, which then relates to the water. However, because of the technology, it can be affected by any salt and material changes to the product, and so this can cause an effect of a drift in the measurement from the material. Older microwave sensors use an older analog measurement technology, and that tends to react with the water as well. But again, they tend to be non-linear because of the way the method of the measurement, and so difficult to calibrate to and have an upper limit which is quite low compared to other sensors. Nuclear sensors are very expensive and tend to be used for high volumes, so getting moisture in a complete storage bin. They also need a lot of maintenance cost because you need specialized staff that have a special certificate for the nuclear sources, and they tend to be not unsuitable for smaller ducts and conveying systems just because of the way that the technology works. Lastly, we've got digital measurement technologies that use a different way to take the measurement using a microwave signal, very high frequency, which is the microwave is taken in such a way that we have a linear relationship with the material. This makes them very simple to calibrate because you're just looking for a straight line. It also makes them very stable over time and temperature, and makes them easy to install, calibrate, and use. They do need a consistent flow of material across the sensing surface, but this can normally be achieved by a good mechanical design and selection of where to install them. So just to take a quick case study to show some of the environmental and cost savings you can get. If we just look at a grain dryer, which is drying incoming grain and that's going into storage, you may want to target a maximum moisture of 14%. If we look at the actual accuracy of the measurement, if that was at 1%, which is still reasonable, but you would need to target a moisture of 13% to guarantee that all of your moisture is below that 14% target. This means you're removing 7% of moisture from the material, and the energy required to do that can be calculated as around 46 kilowatt hours per tonne. If we then reducing that accuracy of that measurement to 0.5%, which is a achievable using a good sensing technology in installation, which has been well calibrated and maintained. We're then reducing the amount of moisture by only 0.5%, so 6.5%, but we're reducing the energy required by about nearly 3 kilowatt hours per ton, which is 7% energy reduction. If we then look at, for example, a 16-ton batch, it was batch dryer. This was based around actually drying rice in India. You can get a higher yield from that 16-ton batch because obviously you've got 0.5% more material or weight of material. You get a lower cost because you save £15 of energy cost. So this is at UK prices. So I apologise for the British pounds. And you reduce the emissions that are being used to dry that grain by over 10 kilograms of CO2 equivalent. Again, this has been done using the UK average emissions values. Just to look at different ways that you can connect this, so looking at future-proofing your plants, all sensors need to be calibrated and connected to the control system to get the online measurement in to use it effectively. And so that can be done in a number of ways. Generally, you'll have sensors in a network that are then connected via things like analog outputs to go into control systems or with digital links. We have the Hydra Hub and HydraView, which are our products to do similar things. They help to calibrate the sensors and give easy interfaces to both the control system and also on Ethernet to the wider area networks and even off to the internet with the right setup, allowing you to then gather that data into plant management systems, into reporting systems, and to obviously to make sure that you're getting the best benefit from your installations. For wider plants and sites with a wider footprint, so some of the bigger manufacturers and processors, you can then connect your different locations using different wider area network links. So just to draw it all to conclusion, in this presentation we've looked at why to measure the moisture, to react to the changes online in the moisture as it's a continuously variable measurement, to give overall benefits of reducing energy cost and also the environmental impact. We looked at where to measure moisture, so in the many different locations around your plant, and how to measure moisture. So using online methods is what we would recommend, and making sure that things are connectable and have good connectivity options. So thank you for listening. If anyone has any questions, then please feel free to come and find us. We're downstairs at J21.
Thank you very much, Neil. Yes, sensors, a very important part of the process that maybe is overlooked for the full benefits that they can bring to us. And we just heard about how it impacts moisture level in product. Now I'd like to turn our attention to, again on sustainability, to the quality control of raw materials that we're using. And we have here Per Hansen from iGrain. He's a biochemist from the University of Copenhagen and has over 30 years experience in industrial applications around grain quality. And he's going to address us on the subject of the advanced mycotoxin detection in stored grain in milling plants. Pierre, do you want to use this or the mic?
Yeah, I'll prefer to use this one. Good. Welcome, everybody. I'm happy to talk to you about this very essential problem, just to put it a little bit into its perspective. Alone in Uganda and Kenya, where we are very active because we have a subsidiary in Kenya, more than 100,000 people die every year from liver cancer caused by aflatoxin in grains. So it's a very serious problem, aflatoxin, as most of you probably know, and it's addressed by the UN as the most critical issue in current food supply chains. Yeah, so obviously we are at the core of things here, because no milk product, no food product will be better than the grain it's made of. And that's why it's crucial that the grain is stored properly, looked after properly, and that's what I'm going to address a little bit in this presentation. Of course, this can only be part of a bigger strategy, the issues that I have time to present here, but other bigger quality control systems can be put in place. So that's really the focus of this presentation, to address some of the most important issues to avoid the generation of mycotoxins in the stored grain. So first of all, why do we get mycotoxins, and where does it start? Well, already in the field, each kernel will have between 1,000 and 10,000 fungus spores on the surface, because the funguses are in the soil. And therefore, the fungus spores, they are only waiting for one thing, a drop of water. That'll kick them off to start thriving and growing. And that is why the entire procedure from harvest to storage and milling is so crucial and important. And so what really is the mycotoxins? Well, first you have fungus, and they are abundantly present. There are more than probably 1 million different fungus species. More than 10,000 have been identified and described, but there are many that are not yet described. Of course, the most famous is two of those that I've pictured here, Aspergillus flavus and Fusarium, which are responsible for some of the most abundant mycotoxins in the food supply chain: aflatoxin, A1, B1, ochratoxin, cerealinone, DON. You probably know some of them. So let's take a look and see what is really happening in the silo. Why is it that grains will generate the growth of funguses that will, in their metabolism, create the mycotoxins? Well, it's relatively simple. If the grain is not stored dry, then the funguses will grow, or insects will grow. And what I've pictured here is actually the most likely route from clean grain to mycotoxin contaminated grain, because the insects will create so-called hotspots where they consume the grain and thereby create heat, water vapor, and CO2, just like mammals. So the metabolism, the total metabolism that's going on inside the silo is the generation of heat, water vapor, and CO2 if the grain is not stored safe at a dry condition and hopefully at a good temperature. So this is the thing that happens, and the hotspot that the insects create will make the hotspot wet, generate water vapor, and that'll spark off the mycotoxins, the funguses. Then you'll get mycotoxins, and then we have the problem. Here are a few examples from the field. You can see some corn cobs here already contaminated in the field. Climate changes have also been accused of some of the problems because the cobs open prematurely. And here we have probably generation of mycotoxins, very bad for the chicken industry, because the time to mature from broiler to slaughterhouse ripe chicken can increase with 5 to even more days because of the aflatoxin. Here's another example, fungus growing on barley. If you are a beer producer or whiskey producer, this is your nightmare, because then whatever you're doing in the malting process, it will not turn out to become a consumer product. Wheat is also subject to a lot of different mycotoxins. Dung is probably the biggest problem in wheat. There has been many problems in Europe in the last 10 years when we've had wet harvests there, but also in paddy rice and other commodities. If you have a little bit wet harvest, then it's not enough to take care of it in the drying and milling process, and that's a problem. So how to detect it, how to avoid it? Well, historically, temperature monitoring has been used a lot to monitor the grain. It's not really a good idea, because grain is very insulating. So a temperature sensor will only see a hotspot if it's actually inside the hotspot. But CO2 measurement that I'm the inventor of in the silo is a very good idea, because CO2 is a gas, and gases will migrate in all directions in the silo, and that's why a simple CO2 sensor in the grain mass, not in the headspace, but in the grain mass, will easily detect emerging insect or fungus growth, and will therefore alert you that in this particular silo you have to do something in order to avoid further growth of the microbiology that will generate the mycotoxins. Here's an example from a flour mill in Honduras. They had a lot of nice durum wheat, and you can see the temperature curves, the orange, red, and blue. They didn't move at all because the hotspot was not where the sensors were, but you can see on the CO2 curve that from day one the CO2 increased a lot, and by the time I got to this site, it was no longer possible to get the wheat out of the silo as a free-flowing grain. It had to be digged out. So this shows the power of CO2 monitoring and how important it is in order to avoid mycotoxins. In order to make everything easy to understand for laymen in the milling industry, or especially in the grain storage industry, we have generated a smart app, and I have even made some algorithms generally available in the scientific communities on how to actually use monitoring data to make an AI-based algorithm to predict both how big a risk factor, meaning the risk of infestation and mycotoxins, and to calculate how many weeks of safe storage would be available in each silo. And as you can see, this is a very helpful tool for anybody in grain storage or milling, because the app will simply tell you online which silo has the highest danger, which silo should you address now in order to avoid further problems. And that's of course a huge help. We have been very successful with this app because it interprets the monitoring data, which normally are only poorly understood by the operators of silo facilities. Here I'll show you how bad things can get. Me climbing into the silo and doing the film. There was 80 degrees in that silo. You can see on the temperature curves that the red curve, the maximum temperature, is going really, really high, and some people in our online center detected the problem and took some days to get the fan started because the rich owner, he was not really easy to get hold of. But the bottom line here is that after you have the unwanted biological process in the silo, it can grow further, especially if you're storing oilseed, and then you may have a serious problem. So what are the strategies to avoid mycotoxins? Well, my recommendation after 30 years in grain monitoring, I can tell you it's CO2, CO2, and CO2, and put the sensor in the grain. That's where you will detect biology. That's where you will see if you have a problem that may come up at a later time. What can you do if you detect a problem? Yeah, of course you should mill the worst silo first. That's what is the moneymaker for you, saving that grain that could be lost with good procedures. That's the obvious solution. Of course, there are operational things you can do. If you have a starting infestation, you can rotate the grain to another silo. You can apply chilling, cooling the grain down. That'll put the biology to sleep. You can use natural fumigation, organic fumigation, which we also deliver. And you can also do other types of fumigation. We are not recommending phosphine fumigation if it can be avoided. It is a pesticide and it's not really effective anymore because of resistance. But there are a number of strategies that you can apply, of course dependent on your total storage volume and in whatever context you are having the stuff, the grain processed in your facility. So we also recommend put in a quality control system on your stored grain side and make strategies so that you can avoid the infestation and avoid mycotoxins. The last thing I want to tell you a little bit about, we have developed a system for natural fumigation, organic way of storing grain. It has some disadvantages and some advantages over other strategies. The bottom line is you can kill the most of the biology in silos by flushing them with nitrogen. We have more than 100 commercial paddy silos in Asia protected with this system. And if you're interested in it, we're available in booth C20 in the exhibition. Thank you very much.
Yeah, thank you very much, Pia. We lose 20% of all stored grain every year. Protecting our grains after they're harvested, or even prior to that, is absolutely essential to sustainability. And we as an industry in both flour milling, feed milling, rice milling have to take more care of our grains. Moving on now, I'd like to move to our second subject that we're going to focus on today, and that is environmental impact. And I'm very pleased to say that we have amongst us today our second keynote speaker, Dr. Surachai Songasompong. Dr. Surachai is an associate professor at Kanseta University here in Thailand. And he's has 25 years in his current role as associate professor. He's an agricultural engineer, post-harvest engineering research group, and agricultural engineering division for the Department of Agriculture and Ministry of Agriculture from 1989 to 99, 10 years there. It's an impressive CV, and he's going to address us this morning on, if I can just refer to my program here, novel methods of rice flour production for environmental friendliness. Professor?
Thank you so much for your kind invitation and it's my great pleasure to come to present here. No, this is my work and my master students' work. No, and we did it for longer than 13 years ago, no, and it's now in the lab scale. No, but I hope in the future I will see this technology making commercialized in the future. So wet milling process is the best method to make rice flour and rice noodle. But the pain point is high usage of water. 1 ton of rice take about 3 tons of water or 4 tons. And then you have a lot of waste water, like 3 to 4 tons of waste water. And then the cost of waste water treatment is very, very high. And you need to have a big facility for waste water treatment that costs a lot. And the production of greenhouse gas during the wastewater treatment, you generate carbon dioxide, methane, and other gas to the environment. And high usage of the machine and high energy consumption that make the cost of wet milling flour highest. And then it takes long time for production because you need the dryer, and then not environmental friendliness. That's why we look for the new technology to replace the wet grinding process. And I want to show that this is the waste water treatment pilot plant of Chor Heng Rice Vermicelli Factory. This is the biggest wastewater treatment for the rice flour company in Thailand. And you see the cost of the wastewater treatment plant is very expensive, and the operating cost also very expensive, and that is in the cost of your flour also. That's why we want to replace the wet milling process. However, for the traditional one, we have wet milling process, dry milling process, and semi-moist milling process. So I want to compare the 3 processes. You see the wet milling, you need the water to clean your grain, right? So 1 ton of grain, maybe 1 ton of water for cleaning. And soaking, you need another ton of water for soaking your grain to make it softer. And then you grind, so you need a new water for mixing with your grain and grind in the hammer mill. So it's about 3 tons already for using of water. And you clean, finally you need to clean all the system, also need another ton. So it's about 4 tons of water for grinding with the rice grain. Then after you grinding, you get the starch solution. You separate it with the separator, and then you dry the wet flour with the hot air. So you get the dry flour. And then you have to sift the flour. So for the wet milling, you need a lot of machine and a lot of labor and a lot of land, and then more flour loss, and then high usage of water and high waste water. So the water footprint and carbon footprint is very high. So people now look for the new technology that is more environmental friendly. And also the wet milling process have high energy consumption, but it's the best quality of flour to make noodle or other non-gluten bakery products, something like that. So the breakage mechanism, there are 2 mechanisms in the milling process: shattering and surface erosion. Depend on the force that you give and the machine you use. Shattering can reduce 2 to 5 times of original size. It means that one piece you break into 2 to 5 pieces. But surface erosion, you reduce the small surface, just in small particle size, but in the middle, still bigger size, then you need to grind longer. And this generates the starch damage a lot. So I want to talk that grinder and the grinding process affect to the quality of your flour. What quality? Particle size, damage starch, and other functional components such as protein, lipid, vitamin, and ash will be moved leached away to the water, right, when you use the wet grinding process. So your flour will have less protein, less vitamin, less ash. And particle size, the small size is better than the bigger size. So wet milling process can generate smaller size. So that's why it has a better quality. And the starch damage is also happen when you grind the rice with mechanical force. The amylopectin fragment is generated, which will disrupt the rice gel, and it generate the damaged starch, and then it will make the flour bad quality and noodle also bad quality. So we look for the new method, that is the freeze grinding process. The rice is quick frozen by liquid nitrogen and then grind in dry milling process. And the temperature of rice is very low. The rice is fragile and break easily. This method is normally used to grind the herb and spice in the traditional way, to preserve the flavor and the odor. So we use this technology to grind the rice. And we have the liquid nitrogen in our department. So we buy the เหลือง 11 variety of rice. This is the whole grain. It's clean already. So we will compare the dry grinding process, freeze grinding process, and wet grinding process. So we used 4 machines. Supermass colloider for wet grinding process. Roller mill, hammer mill, and pin mill we use for dry grinding process and freeze grinding process. So in the wet milling process, we soak our rice with water 1:1 ratio for 4 hours, and then we grind with the new water in the supermass colloider machine, and then we separate the water out of the flour by basket centrifuge, and then the wet flour is dry in the tray dryer. And then after we dry, the flour is stick to each other, so we have to mill by hammer mill, and then sieve to 100 mesh, and then we get the very fine flour and pack in the plastic bag. For the dry milling, we use our rice. We grind into coarse grinding because the machine is small. So we need to coarse grinding by using the grinder, and then we dry milling by hammer mill, roller mill, or pin mill, and then we get the flour. And we need to sieve to 100 mesh sieve, so we get a small particle of flour, and then we have the bigger size, so we have to grind again the second time, and then pass the sieve, then we get the flour. But for the freeze grinding, we use liquid nitrogen to mix with our rice and then grind in the dry grinding process, and then we pass the 100 mesh sieve, and then the bigger size we have to grind it again second time to get the lower size. So we measure temperature and time of production, and measure the yield after milling and sieving, and measure moisture, damage starch, particle size, and using the scanning electron microscope to see the size of our flour, and then measure the viscosity of the flour. So all these things are the quality parameter that we want to know and compare. No? So after we make the flour, we make noodle also, because the main user of the flour is the noodle industry. So we try to make noodle and compare all the grinding process. So this is how we make the noodle. And then we measure the texture of the noodle and texture of fresh one and rehydrate one, and measure the whiteness of the noodle. So this is our abbreviation. W mean wet milling, R mean RH, and P mean dry milling with the machine, roller mill, hammer mill, pin mill. And RF is roller mill freeze grinding. HF means hammer mill freeze grinding, and pin mill freeze grinding. So let's see the temperature. You see, when we freeze the rice grain with the liquid nitrogen, the temperature is less than minus 170. But after milling, the temperature increased, but it's still cold. But after the second milling, the temperature still cold. But for the wet milling process, the temperature always at room temperature, not too hot. But when you grind with dry grinding process, the temperature increase a lot, so it's very hot. It means that your starch damage increase a lot. And the grinding time, you see, the dry milling process take longest time, but the freeze grinding process take very short time, same as wet milling process. Now see the yield. When we use wet milling process, we get less yield after milling. But dry milling and freeze grinding process, we got higher yield, because some of the flour go with water. But after sieving, you see that there is a bigger size, so you get lower yield in some grinding process. But for the hammer freeze grinding and roller freeze grinding and roller dry grinding has higher yield than wet process. And this is a total yield. It means that 100 grain that you process, you get this amount of flour. So roller mill dry grinding and roller mill freeze grinding get the highest yield. But the hammer mill freeze grinding also higher than wet milling process. Wet milling is the third one. So this is, we use statistic to compare. So wet milling show less final yield than the roller freeze and hammer freeze grinding process. And the moisture, you see, normally the moisture is less than 14%. But hammer freeze, you see, 15%. It's because of the condensation of water from the air to the flour. That's why you need to keep the room, the humidity of the room dry. I suggest this is just normal humidity in Thailand. It's about 70 to 90%. But you need to keep lower relative humidity, so you will not have the higher moisture happen. Now, how can we check the damaged starch? Now, we use enzyme from Megasam company. Now, we follow AACC method. So we use the enzyme to digest the starch damage into glucose, and then we use glucose oxidase to create the pink color. And then we measure the absorbance at 510 nanometer, and then we calculate the damaged starch. So you will see that the wet grinding process has lowest damaged starch, just 2%. But the dry grinding process has the highest damaged starch. So this is bad quality for noodle or for gluten-free bakery product. But for freeze grinding process, it's intermediate. It's higher than wet milling, but still lower than the dry grinding process. And you see the size of the grinding flour has a small size, and also this is small size and this is bigger size. So you need to have sifting. And the bigger size you have to grind the second time. You see always. So I want to mention the average size of wet milling process is smallest, right? 61 micron. But dry grinding process, the size is about 100. And freeze grinding process also about 87 to 100. So freeze grinding and dry grinding process has similar size, bigger than wet grinding process. And this is the picture from scanning electron microscope. You will see that the wet grinding process has a round shape, but other grinding process has more corner and bigger size. So wet grinding is the best. And I think freeze grinding by roller mill and hammer mill is also good alternative. So we want to compare the viscosity. The wet grinding process flour have highest viscosity. You see the highest graph. But the other has the similar graph, so lower viscosity. You see. But it's still good to make noodle. I will show you later. So this is all the data that we got from the graph. Now, power consumption. You see the energy cost, the power consumption in each milling process. You see the wet grinding process has the highest energy consumption. And the price of the electricity, water, liquid nitrogen is shown here. So I want to calculate the total cost. You see the wet grinding process has used highest energy for grinding, and the cost of grinding also and drying also very expensive, and the time of production also longest, right? But the freeze grinding process, you use less energy than the dry grinding process, and also the cost lower, and also time also shorter. So this is a good alternative process. And when we make noodle, we have to adjust the solid content the same. So this is how we adjust the solid content. And then we make the noodle, and then we measure the texture of noodle. So now I want to compare hammer mill freeze grinding and roller mill freeze grinding with the wet grinding process. Now you see the tensile strength is similar now, and firmness also similar. And texture, wet grinding, hammer mill freeze grinding, and roller mill freeze grinding have similar texture. And the cooking property also similar. And the whiteness index of the noodle also similar. And when we use sensory evaluation, the consumer, they cannot differentiate the quality. They feel the quality is the same. It's not significant difference. So in conclusion, freeze grinding process is an alternative method to replace the wet grinding process. And hammer mill is the best. And the small particle size compared to the dry grinding. So freeze grinding gives smaller particle size than dry grinding and less damage starch, more yield, and not different size, and the viscosity not different with the dry grinding process. But the wet grinding still show highest energy consumption and highest cost. And the freeze grinding use less energy and less cost, similar to dry grinding process. And the noodle quality is not different with the wet milling noodle. So now we compare freeze grinding process, so we can clean the grain by air and use liquid nitrogen soaking and then dry milling and then sifting. That's all. And no loss of the protein, no loss of mineral, fat, vitamin, and other. And starch also less loss. And the average particle size is medium, and the damage starch is intermediate. And water use, no water use, no wastewater, low energy consumption, and high environmental friendliness. So this is a new technology that I hope that the company will use it in the future. So we need to have a large-scale production. And this is a system from air products and chemical that they have the feeding in the hopper, and then they add liquid nitrogen. So liquid nitrogen is mixed here. And then your rice is frozen, and then grind here, and then sieved. So the bigger size go to the second grinding, but the smaller size you can pack, right? So this is just simple technology that can be used. And we publish in Journal of Food Engineering for 13 years already in 2011. And after that, the Korean Society invited me to present in Korea. So they will use this technology for environmental friendliness, and they make the gluten-free bakery product. So you can see that they cite my work a lot. And for me, I make instant high GABA fermented rice noodle by this technology. It means that if I use wet milling, the GABA will go out with water. So in my flour, we don't have GABA, even we create it already. So freeze grinding is a method, is a very good method to preserve the GABA in the flour and in the noodle. And I can make wide strip rice noodle and thin strip rice noodle from freeze grinding flour. And I can make the Thai dessert from rice. You know, khanom krok. This is the rice and coconut milk, sugar and salt. So the consumer cannot differentiate that I use a dry grinding process or wet grinding process. But normally, company use wet grinding process. But consumer cannot differentiate at all which one. And this is the rice with the banana steam product. It's a kind of dessert also. Consumer cannot differentiate between wet milling and dry milling and freeze grinding process. Now, I want to talk about GABA rice because gamma aminobutyric acid is now a functional food in the germinated rice. No? And if you grind in the wet grinding process, you lose the GABA in the water, so you cannot get the GABA in your flour. So if you use freeze grinding process, you can preserve it in your flour. So we can make GABA flour. And this one also a challenging one. We want to make rice vermicelli that still have GABA. So I use freeze grinding process to make flour and make the rice vermicelli. So we call GABA rice vermicelli. You see, we can make it by using this technology. And extrusion. If you want to make extrude GABA snack and you still preserve your GABA in the snack, that's why you need to use freeze grinding process. And in the making of color rice flour, now you want to preserve the bioactive compound. If you use wet grinding process, all the bioactive compound mostly go with the water. Then your flour don't have the bioactive compound like a phenolic compound, something like that. But if you use freeze grinding process, you still preserve that component. Okay, that's all. So I hope that in the future, the company will use this technology to make the rice flour and noodle and other food products. Thank you so much.
Professor, thank you very much for an enlightening presentation. And that technology is over a decade old and has still not come into production, which is interesting in itself. Now, we have a presentation being loaded at the moment, but it gives me a chance to introduce our next speaker. And by the way, this is the second in our environmental impact presentations before we move on to energy and the final two presentations. But now we're going to hear from the founder of the Maximised company. And this is, excuse me just a second, I've lost my place. And it's great pleasure to introduce Tipup Borman, who is the founder of Maximised group of companies. He founded the company in 1996, and he's going to talk to us on the alternative subject to what we've just heard. He's going to address embracing sustainability, the environmental benefits of rice flour processing through the wet milling technology. So we're going to have a contrasting presentation here.
สวัสดีครับ Ladies and gentlemen, esteemed guests, I have to say special thanks to Professor Surichai talking about rice flour through wet milling technology. That most of the speaker talking about wheat flour. Now we have to change your mood to understand the transforming from wheat flour to rice flour, particularly transforming the whole grain barley flour to wheat flour. I will talk about the new technology, the new world technology and innovation to transform rice grain to rice flour by, we call the compact platform, rice flour processing compact platform. That the newest technology, the new innovation, it came from the traditional processing in Thailand that Professor Sirichai talking about the wet milling process. But in my session also, I will talk about sustainability, the environment, or energy saving. Today, I stand before you to shed the light on a remarkable invention that is not only revolutionized rice flour processing, but also promotes environmental conservation and sustainability as well. It is my privilege to introduce you to the transformative potential for the Max Series rice flour turnkey processing by wet milling technology. This is the newest technology for rice flour processing to the compact platform. You have to understand that in the whole world, particularly in Thailand or in Southeast Asia, many years ago, I can say more than 40 years ago, we started the wet milling technology for rice flour to wet milling process by using a huge space for the production. But for the newest technology, we use a small space for the production line. And also we can produce various kinds of rice flour, not only rice flour or glutinous flour. But anyway, as I said that in my session, I emphasize to talk about the sustainability, the environmental or energy. So anyway, it's my privilege to introduce you to the transformative, again, to the potential of Max Series rice flour by wet milling technology. In our world, where water is scarcest or less and less consumption, wet milling offers hope. Unlike traditional dry milling method that use a lot of energy for dust control and cooling, wet milling requires less water by soaking rice grains statically. We use water more efficiently, saving this precious resource, especially in areas facing water scarcity challenge. Additionally, we use innovative water recycling system to further reduce water usage, demonstrating our commitment to responsible resource management. Our path to sustainability includes saving energy with the Max Series wet milling technology. We use much less energy compared to regular dry milling. Soaked rice is easier to dry, needing less energy. Also, we skip steps like heating and drying, which usually take up a lot of energy. By using the Max Series and wet milling by the newest technology, we are not using we are not just cutting down on how much carbon we release, but also supporting worldwide actions to fight climate change and protect the environment. At the heart of our effort to take care of the environment is cutting down on waste. With the Max Series and its wet milling by the newest technology, we produce less waste compared to dry milling from traditional method. Soaking rice grain helps separate the useful parts from the waste parts better, meaning we make less rice bran and husk waste when we process rice. This shows we are serious about reducing waste and following the idea of using resources wisely. In addition to helping the environment, the Max series by wet milling method also make better rice flour. Soaking the rice make it softer, giving us fine flour that tastes and it feels better. The top-notch flour sell for higher price, giving producer more money when they use wet milling by the newest technology. Plus, because wet milling makes great flour with fewer steps and additives. It is even better for the environment. We use fewer resources and make less waste. Certainly, here are the selected points and endorse environmental sustainability. Max Series rice flour is highly valued for its excellent quality compared to flour made using other methods like dry milling or semi-wet milling that Professor Sirichai talking about. If you saw it about dry milling method, about we call semi-wet or whatever, but we emphasize wet milling technology or wet milling process. This shows that the Max series makes really good rice flour, which can help us use resources better and make less waste. Max series rice flour is famous for its long shelf life, lasting up to 2 years. This is thanks to special heat treatment process used for preserving food. By making rice flour last longer, the Max series helps reduce food waste, which it is great for the environment because it means we are throwing away the less food. Max series rice flour turnkey processing compact platform is incredibly fine, going beyond 100 mesh or 150 microns. It made to fit exactly what the customer needs, with the option to adjust the size as required. Being able to produce such fine rice flour means we use our material efficiently, cutting down on waste and making the most of our resources. Unlike large traditional milling process that need at least 1,000 or 2,000 kilograms per hour of materials and a big industrial area for setup. The Max series is smaller and designed for handling smaller batch of materials. The compact design of Max series saves space and resources during the installation, which helps us be more efficient with resources and promote sustainability. With its unique design, this product minimizes the use of raw materials. One great thing about it is that it needs small amount of raw materials for each production round. Additionally, it is easy to switch between the different raw material. As I said, you can produce rice flour, glutinous rice flour, riceberry, basmati rice, American rice, any kind of rice. Just deliver the incoming raw materials, okay, into our processing, and then the finished product will be the rice flour in certain kind of rice from input to rice flour, right? With the unique design that this product minimize the use of raw material, one great thing about it is that it needs smaller amount of raw material. I have to say again, for each production line, additionally, it's easy to switch between different more raw material. I repeat again, because this is a newest technology. Again and again, that in Thailand, in Southeast Asia, in Japan, most of the processing line, they use just one kind of the material for the processing, transforming from rice grain to rice flour. Using raw materials efficiently help us reduce waste and operate in a more sustainable way, which is better for the environment. We got easy, convenience, and safe cleaning method that meet FDA, SSCP, Halal, and GSP for food safety protocol. These methods make sure our food prep and handling are really clean and hygienic. Following this food safety protocol help us run our production in a way that is good for the environment, keeping people healthy and supporting environmental sustainability. Our rice flour produces is gluten-free, making it an ideal option for individuals who have a gluten allergy. Giving people gluten-free rice flour meets their needs for healthier and more sustainable food choices, which helps the environment by encouraging diverse and inclusive eating options. These points show how the Max Series rice flour turnkey processing compact platform helps the environment by using resources while making less waste and following food safety rules. In summary, using the Max Series rice flour turnkey processing by wet milling technology, it is a big step toward sustainability as the people responsible for the environment. It is important for us to use new ideas that it is not only makes things better, but also protect our planet for the future. Let us keep moving forward with the Max Series by wet milling method, that it is the newest technology and innovation to build a future that is more sustainable and stronger. Thank you very much for your kind attention. ขอบคุณมากครับ If you have any question to ask me, if you have any doubt about the newest technology, I can guarantee that the Maxury compact platform is the newest technology in the whole world. That is for the SME. It is for the country who need to import any kind of rice grain anywhere in the world. If you have rice grain anywhere, when you import it, you can produce that kind of rice flour for our new technology. You don't need a big space. You don't need more energy. You don't need anything that you spend a lot of money. Just import, okay? Or using your rice grain and then transforming to rice flour. At the end of my speaking, I have to emphasize that in the whole world, you have to change your mindset. By eating wheat flour, that you have the gluten allergy, it's very dangerous for your body. For IBS, celiac disease, very harmful to your stomach. Change your mindset to eat rice flour, particularly brown rice flour. And then you can study in milling and grain biology about the knowledge, the education, how to transform, how to substitute from wheat flour to brown rice flour. Thank you very much. ขอบคุณครับ
Thank you very much. I think we've heard a couple of contrasting presentations there, and I think changing our mindset is what we're all about. We have to be open and aware of what is happening around us in order for us to move forward. So it's good to see these two gentlemen teaming up over there as well. Now we move on to energy and to a very important part of our meeting today, and is to introduce to you our next speaker. Okay, Raymond Ma has come all the way from China to be here today, and it's a great privilege for us to have him in our presence as he represents what I believe, and he may correct me here, the largest flour milling manufacturer on the planet. It's not often we get a chance to sit in the audience and listen to somebody who is doing so much, in my terms, for food security. And he is not the only one up there. I believe the top 5 flour millers on the planet are in China. We've heard from Bagasari today, which is internationally one of the largest manufacturers as well. So we're very privileged to have these gentlemen with us. Raymond is going to speak to us as a keynote speaker on the introduction of Wordley and the revolution in equipment and technology in the plant. And while he's coming up, Raymond, please join me. I had the privilege of visiting this company something like 4 or 5 years ago when they were completing their number 11 mill. Maybe that's it in the picture there. A huge development. And at that time, they were manufacturing just under 50,000 tons of wheat a day. I'm sure it's much more than that now, and hopefully Raymond will enlighten us. Raymond, the floor is yours.
Thank you. Ladies and gentlemen, thank you first. I want to give my thanks to Tootie. Because Tootie invited me last time, I rejected because I'm a little bit afraid my language. So this time I accepted. So I tried to challenge myself. This is actually there are 2 firsts for us. The first is that for Woodley, it's the first time for Woodley to going abroad, to be on an international stage. I heard a victim for many times, but this time going abroad. The second first is that for myself, I've learned English for many years, but this is my first time to delivering a speech in such informal English. So I try my best. Please forgive me if some mistakes. So Woodley is China's company, family owned. And first I play a video for 5 minutes to let you know. Okay, how to play the video, please? For the 5 minutes, maybe. Thank you.
我认为，中国作为世界最大的小麦生产国和消费国，最大的面粉企业应该诞生在中国。我们乌德里人有信心、有决心、有能力，把企业发展成为世界最大的面粉加工企业。
Okay, thank you. Okay, very small video about the company. So I want to give you an introduction about our company. So our Chinese name is Woodley. Wu means 5. De means get. Li means benefits. It means 5 partners can get benefits from our value chain. So what are the 5 partners? The first is that the customers. The second is farmers. The third is employees. The first is country. The last is our company. So it's a kind of philosophy Chinese culture, we need to balance the 5 partners. So you can see the contact, the meaning, which is very important because China is a socialism country. We are very focused on social responsibility. So that's very important. Okay, sorry. It's a newest one. I have an image here. Yeah, it's a new one. The image inside. We have leading capacity. That's our biggest specialty. It was founded in 1989. That was a small milling line with 15 tons each day. So we getting through the very big, yes, this one, yeah. We are getting through very quick development because of China's economy. This is the first one is our founder, Hong Dan. He is born in 1940, still alive. Second one, the chairman, the Zhimin Dan, our chairman. And the third one is Zhi Guodan, 2 sons, and her father built the company for many years. The last one is my father-in-law. This is her daughter. Thank you. So there are 16 million factories, locations, and 1 noodle factories in main good wheat planting provinces in China. This is China map. Our business focusing on the Chinese market, domestic market. We don't have any business in abroad. These are some statistics in 2023. We have 25 market share in last year, and the second is Costco. Second is Walmart in China. The third is the Costco China. So in total, we 3 companies dominate about 0.5% market share in China. Last year, we milled more than about 20 million ton wheat in last year. We have 3 billion THB sales revenue. We rank top 500 companies in China. So the second part, I want to give you a brief overlook about China's milling equipment, factory inside images. 35 years, we are only focusing on the wheat milling. We don't have any other business. Okay. Okay, from the wheat intake. This is the wheat sampling, unloading. This is our auto sampling, the pre-check, then pre-check, unloading, pre-cleaning, waiting, final check, and the pricing, auto payment. It's a very quick process. Maybe only 10 minutes when from the truck arrived. A little bit different from other countries. Most of our wheat are delivered by trucks, about 34 ton each truck. So because very large capacity, specialty for China's milling factory is that we have independent cleaning section. We concentrated our cleaning section, cleaning machines into one building. It's apart from the milling part. This is the cleaning machines. This donor recycling, air recycling, classifier, upgrader, task. So this is the milling part, only for three persons in one shift for 3,000 or 6,000 each day, the milling factories. The biggest, especially for China's milling, is big. We have a very big line, milling line in one building, on one roof. The biggest one is 6,000 ton per day now. Maybe four lines or 6 lines inside. So this is the image, 6 floors. This is the packaging, mixing, auto packaging now. We try to use a new machine. And this is the warehouse, ASRS warehouse. We are the first company to use ASRS warehouses in China, because this kind of warehouse is very expensive for China milling company, and we still have some difficulties about using this because there's no hoop. There's no hoop in China's the pallets. There's no. So many millers they are afraid. They are worrying that maybe it's have some problems with that. The first one in China. Now the warehouse has 700,000 pallets inside. This is the palletizing and the truck loading, the differences between. Because there's no domestic pallet transportation or distribution standard in China. So when we sell the products, we need to depalletize and a little bit different. So the forklift push into their truck. So you can see very high efficiency. The third part is about the company's concern about the quality. Why we here? Why we are so big in China? The biggest reason is that we are so care about the quality. We have a lot of invention and innovation about the quality. In 30 years before in China, we can only produce 0.8 ash content or 1.0 ash content of flour for eating flour yield. For people's eating flour yield, maybe the flour yield is 85% or 80%. It's very high. In 2000, we visited the Japan or Korean milling industry. We got to know the lower ash content. So in 2000, we can produce the ash content 1.06, 1.56, 0.5. In 2012, we can produce the ash content about 0.43, maybe around there. So we keep ahead all Chinese milling industry about the ash content. So China has very speciality in food. Maybe a little bit different other countries, but it's typical in all Asia. This is the main Chinese flour-made food: steamed bun, stuffy buns, or boiled dumplings, boiled noodles. This is for baking. Baking, fried. Baking noodles, dry noodles. It's a typical. So These are our main products, media and strong gluten. All Chinese wheat, most of our wheat are media gluten. But now people getting, preferring transfer to the higher gluten, strong gluten. So we have some strong gluten products. We imported more than 1 million imported wheat in China. Most of our products are packed by woven bags or non-woven bags. And the downside is the plastic bags. China's market has very few paper bags. We had a little deep-made flour business. It's dry noodles factory, 1,000 tons per day. The capacity, our brand is Tianmairan, our brand in China, but a very small part of our business. This is some dry noodles products. Dry noodle accounts for 10% of 10% China, the flour used. So we care about the food safety. All our factory is certified by SDS. So the first part, I want to talk a little bit about flour maximized, flour milling maximized. This is a very important topic for China. Why this? As you can see, I give you the percentage of China's milling cost. The net profit margin is under 5%. And in the past 2023, all China milling companies are suffering heavily loss because of the serious overcapacity and the large fluctuation of grain prices. So in the last year, we just got 1%, 2%. So this is the list of cost percentage of sales price. So you can see the wheat accounts for 80%, 85% of the sales price. The producing cost, 47%. Inside the labor, in China's labor is cheap, and also we use very, very, very few people in our country, in our factories. So the labor is under 1%. Electricity cost is between 1 to 1.5%. All other fees, 3 to 5%. So the flour milling maximized a very big topic in China. So about energy saving, I give you a brief conception. Most of our factories is under 58 per ton wheat, and the average is about 55 kW hours per ton. So we are very care about this. We try to lower our cost. The most important way to reduce the cost is that we try to maximize the capacity of our one factory, the scale. Most of our milling company, the factory is 3,000, 4,000, 5,000, 6,000 tons each day. We don't build 1,000, 500, even 200, 2,000 tons per day capacity of the milling factories. So the second is automation. Automation is a large trend for the last 10 years. We have very good automation now. We cooperated with Bueller China very a lot. So the third is equipments. Most of our equipment is coming from below China. We have a good collaboration with Philip. Thank you. The last is very important in past 5 years is the informatization and smart mill. I give you a map structure about China's structure of informatization. We cooperated with builder to build this. We integrated from the weight intake, the truck unloading, milling control, and the packaging, formula management, and then truck loading, quality control. So, you know, China's mobile internet is very popular. We even don't have a wallet with ourselves. We can pay, e-pay is very popular in China. We don't need to bring any cash. So many business is working on the internet, working on phone. So the informatization works a lot, especially in past 3 years pandemic, it worked a lot. So this is our understanding about the China's milling industry. It's a main and a typical. You can see the China's milling industry. So the last I want to thank, and when I want to send invitation to everyone here, if you have time to China, come to Woodley, come to Handan. Thank you.
That's the most stimulating presentation that I've experienced. I think I've never seen a video like that, and maybe I won't see one again in the future that shows so much technology, equipment, and development that's gone into a company in the past 30 years or so. I mean, it is phenomenal, and we're very privileged to hear about it. And thank you for the kind invitation. I'm sure many of us here will, or several of us here will like to take you up on that invitation. Right. Now, following up on that, I'd like to invite our second to last speaker. We just have 2 more to go. Just a second. I'll try and get my program back again. We have Philippe Frischti. You'll have to. Yes, Frischti. He's the Director of Food Technology in Asia for Bula, and it's quite appropriate to have Philippe here to follow up on the presentation we've just heard. And of course, he's going to be talking about energy as we are coming to the conclusion of our program, and he's going to talk about the transformations in the wheat processing industry. Philippe?
Thank you.
Please.
So I hope you have a little bit energy remaining for the lunch is soon. Lunch is soon. We go. I hurry up. Huh? So I want to start my speech to emphasize the title of the conference, and it's Maximizing the Flour Milling Industry. And I think you can maximize out of many, many perspectives. You can maximize out of what is our asset, but also cross-country communication. I'm Swiss, I'm living since 8 years in China, so we know each other very well from Woodley, so we work very close together. But maximizing has different perspectives. It's cultural perspective, it's business perspective, but also from a sustainability point of view, power point of view, many things you can look to it. Why we need to think about maximizing is we have many, many operation challenge nowadays in many countries over the world, not only in China, also in Southeast Asia, in Europe, and we struggle. The industries struggle. So we have to work together. We have to exchange the knowledge. Only like this we can achieve the next step together. When we talk about sustainability, we also have to think about stability. So very often we talk about peak performance, but peak performance is good, but also we need to think about stability. How to run things stable continuously, same like Raymond before mentioned. It's not the capacity which make it, it's to run the capacity every day, which make it then happen in the end of the year. But also food safety and cost efficiency, operation improvements have to be addressed. With all of that, our labor skill, in the end everything is happened by the people. Even we have only a few people, people make it happen. And our people is like a capital. And we have to think about how do we work with those people better together. It's not the same as before. So we have to think about it's a transition to the new people, to the new generation. How do we work them? How do we engage them in our factories, into our production, while they will maximize? The machine, of course, will maximize itself. No doubt, this will happen. But the people need to support it. So, Bühler created a project which is Smart Mill. Smart Mill should unlock this potential of, first of all, how does machine work together, but also how does intelligence support the people? How does the people get help from it to get all this benefit? And of course, smart manufacturing is moving and moving, so also with cyberspace, we have to think in different perspectives how to make this happen. In the end, we have to capture the value of high automated plants. So we heard before as well, high automation will enable a lot of things. That means profitability, that means maximization, that means energy optimization. So this is the groundbreaking of it. But to really capture and capitalize all this benefit, we need to think in two pillars. One, it's automation, but the new part, it's digitalization. So in the new digital world, we heard also from Bogasari before, so you need to upload in dashboards, you need to visualizing stuff to the people. Only like this the people know and they will improve. Same like your bank account tells you it's full, so we go shopping, or it's empty, we stay home. So it's exactly the same principle. And when you look into online sensors, for example, they do help. So you show the yield, you show the productivity to your operators, to your managers, to different levels of your CEO, and they will, by their intention, try to do better. If you let them know, they do better. Same, your wife, bank account full, she do better in spending. That's normal. So this helps customer to increase, to maximize their production. I think this is a step where we have to learn that this is not automatically happen anymore. We have to engage each other to do it too, to make it happen. But also on the dimension of machine, we have to think about how do we make loops, how do we make smart actions happen in a smart mill. So how does machine start to optimize themselves, that no people need to go to touch? So we have a program in China, for example, where we do smart mill loops. So we, for example, make brake release loops, so we automatically adjust the brake release. So these will help that people do not have so often to go to check again. Raw material changed, raw material fluctuates. So we have to also adapt according to it, or also like protein loops, how do we save raw material costs, but as well flour ash loops, color loops, whatever kind of loops you have a sensor, you have a system above, and you start automatically to adjust the system to it to stabilize on one hand, but with stabilization you can also increase your peak performance. Now I like to go to another perspective of maximizing. We have in Europe our program MIL E3. What is E3? It stands for 3 efficiencies: space, time, and energy. So when you build new plants, when you look into your existing plants, try to look from a different angle to it and try to think, what should it then be in the end? If you make the benchmark a certain level, as well again, people try to catch the benchmark. If the benchmark is low, they will stop earlier. If the benchmark is high, they will go up. So that's as well we do that in terms of MIL E3. MIL E3 is a concept where we try to maximize the floor of the building. Can we achieve or not? It depends many factors, but at least this should be the goal, to save energy, space, time, to get this additional efficiency. We have this done in Europe already with a customer in England, for example. There was our first plant we have done, and we could achieve 16% less time, 20% less space. 8% less energy over all the plant, just with trying to approach, try to brainstorm together, how do we can make this happen? Is it really the concept? Is it customized? Let's stay that open, how you want to build things. If it has to be fast, it has to be standard. For this, we also develop machines. You also see downstairs at the Victam, you see many, many machine manufacturers which go for higher efficiency machine. Of course, this is part of it. This is no doubt. With our daily activity, we should think about carbon saving. Carbon is one part of a popular word, but in the end, it's about energy saving. So we have to think about how do we adopt this into our DNA of thinking about. Many people say, yeah, carbon is my priority. If the wind changed, my priority is different. So priorities are okay to make strategic initiative, but we have to think about how do we convert this to our culture, how to look at it. So when we design in our daily work, when we work in optimizing, we have to learn just to a natural optimization. I deliver something, okay, let's review, let's optimize. It's kind of a cultural behavior, and like this you can impact huge to the industry if you just start to review. It's also, in the 1980s we call this quality. Nowadays we call it in a different word, but it's the same. Huh? And with this one, we can achieve substantial savings. These have then, of course, also a very big impact. So if you look, for example, a carbon footprint of a flour mill, we can also look at and say, okay, raw material is a major contribution, then less raw material I use, then better is my carbon footprint. But also we have to think in our logistic, in our grinding, how do we can do and how do we quantify this tool to get a carbon footprint. We as industry, we all the time talk in percentage, we talk in kilowatt hours, but I like also to bring the example of trees. So we have to learn as well to talk a different language. We have to convert our language. Our consumer cannot understand kilowatt hours. Our consumer understands, okay, this is a tree, you save one tree, logical. So we also have to start to learn how to messaging, how to amplify our message into the industry, that also we try hard. And I appreciate the whole industry which working hard. To my last perspective of sustainability, it's become to nutrition sustainability. Often it's get overlooked that we have a certain amount of resources and we have to think about how do we use these wisely. If we waste resources, if we waste temperature, vitamins are gone and everything. So we start to establish the concept of healthy, which is really the premium food, but also staple food can be healthier. So if you just help the people to be a little healthier, actually you help many, many people to improve a lot. And with such a concept, we can also start to improve and contribute to nutritional value. So I brought an example for you here. So this is normal staple food, and in normal staple food, we start to add whole grain flour. I know, 100% whole grain flour, more healthy, no doubt. But the adding a little bit whole grain flour makes many impact to many, many, many people and makes it a little healthier. And if we give people a choice, people will do a good choice. I'm trust on it. So we educate our people in many, many countries. So we give them a choice. And with this one, I want to give you not the choice to go lunch. I give you the choice for the next speaker. Thank you very much.
Thank you, Philip. Excellent. We should be breaking, well, we'd like to break for lunch. We've just got one small presentation to come, and we're returning to rollers. And we are fortunate to have Lee Dion, who's an engineer with an MBA, and he serves as the Asia Pacific area manager for Yana. And he's going to talk to us finally on how to recondition rolls to improve mill performance. Lee? Yes. That's the pointer, and that's the slide. Thank you.
Okay, Sawadee Krap. Good afternoon, ladies and gentlemen. I'm Lee Dion. I think you all are all waiting to go for lunch, so I'll make it fast and quick. So today I would like to present about how to recondition rolls to improve mill performance. Okay, just a very brief intro. So Jena currently is one of the world's largest and leading flour milling rolls manufacturer. But just 10 years back, when we started visiting flour mills in Southeast Asia, nobody wanted to buy Jena rolls. We visited many mills, and mill after mill, we got rejected and rejected. But luckily, we met a few kind flour millers who bought 2 rolls from Jena, and they tested it in their roller mill. And they also checked for roller mill performance, and for many, many months, they checked the roll conditions. Luckily, Jena rolls, the quality of Jena rolls was good, and the rolls lasted longer than expected. So along this journey, we met a few superstar flour millers, and they taught us many things. One of the things we noticed is that these superstar flour millers are very particular about many tiny details in flour milling. Example, they are very particular about the importance of correct flute profile, taper, roughness, as it affects many things in the mill. So they also tell me it is very important that when we do rolls reconditioning, we must do it correctly and regularly. So you can see here, this is the fruit profile. There's many specifications to follow. So when the grain goes into the roller mill, if you have correct flutes, you can easily cut open the bran and scrape the endosperm away from the bran. But if the flutes are wrong, instead of cutting it, sometimes it's smashing and grinding the bran, leading to high ash consumption, high electricity consumption, higher moisture loss. So here you can see it's an example of a fluting table, and you can see there are many specifications of the break rolls, flutes profiles. This is the specifications for the reduction rolls, taper. So for reduction rolls, it looks like a perfect cylinder, right? Like this. But if we measure, we will actually see that there is a taper at the end. And why we need the taper is because on this shaft here, there's a bearing, and when the rolls turn, the shaft, the bearings will generate heat, and it will heat up and expand the end of the rolls to look like this when the rolls is turning. So you will get even gap throughout the rolls. But if your taper is wrong, or if there is no taper, your rolls will look like this when it's not turning. But when your rolls are turning, the ends will expand and it will look like this. So you get uneven gap throughout the rolls. Here is a too small gap, so too much starch damage. And here, too big gap, so too little starch damage. Okay, so rolls reconditioning is troublesome because it's challenging to recondition rolls accurately every time. Mainly because most mills, they are using a manual or a PLC semi-auto machine, which looks like this. You need a very skilled operator to operate these machines. Yeah, there are many manual controls. So example, if even you have to control your cutting depth, you don't know how many microns deep your cutting tool has gone. Or even to make this taper here, what you have to, the rolls are moving left and right. So they have to turn the wheel to control the grinding wheel in. So when the rolls move left, you have to push in the grinding wheel by how many microns, and when the rolls go right, you have to pull out the grinding wheel in how many microns, and you have to do this at a constant same speed as before. So it's very difficult, and you have to remember where are the backlash. So I spoke to some operators, machine operators, even they have 20 years of experience, and they also told me that to make the taper, it's difficult, and to make the left side and the right side of the rolls the same taper is also difficult. Okay, then another thing is many mills, they don't have the machine to check also for their flutes. So if they have a machine to check whether the flutes are correct, it is easy. You see here the angles, we brought our machine to some of the flour mills, and when we check the angles, sometimes it's wrong or the land is wrong. Yeah. So how to recondition rolls effectively? I will go very fast now. Basically, it's to use technology, use a CNC machine, a computer controlled, and then follow simple procedure and use a fluid profile measurement device to measure and check your results. So this is the Yenar CNC machine. It's easy to use. It's, you can train an operator in just 3 days. And you don't need a skilled guy. So this is the Yenar factory. We have 13 CNC units of Yenar machines here in our fluting factory. And we flute about 50 to 60 rolls per day. Would anybody like to guess how many people is working to operate these 13 machines? How many? 13? Oh, only 3 people. 3 people to operate this, because with a CNC machine, it's much easier. So here are the steps and procedures and steps. First, you basically measure you install the roll and you measure the diameter, make sure the diameter through, and then you have to do the grinding to make sure the diameter is the same throughout the rolls. And then you set roll and grinding wheel position, you align the roll parallel to machine. I won't go detail. And then you key in the grinding parameters, and then you press start. And if you would like to choose the taper option, you can also choose the taper option here. Oops, what happened? Okay, so this is a layout. So here, normally the sandblasting machine is beside the fluting machine. So this is the sandblasting machine. So normally we do about RA of 3 to 4 RA. This is sharpen the tool. And when you do fluting, first you install the cutting tool, you make a chamfer, and then again you have to set the roll and tool position. And when you do refluting, don't need to grind the rolls until it's fully flat like this, smooth. You can just grind the rolls until the diameter of the rolls is even throughout the rolls here. And then you follow back the flutes. You have to put your cutting tool, adjust it exactly to the belly of the flutes. And then you press start. And you can key in all the grinding parameters. Yeah, first you press start. So it's much easier. So another thing, when you do fluting, make sure to check for your fluting profile, whether it's correct or not, by using a roll care, a flute profile measurement device. You can also use this device on the roller mill to check if the rolls are worn out, the flutes are worn out or not, and a report can be produced. So, as you all know, it is very important to have accurate rolls profile and frequent rolls reconditioning, because it affects many things in the roller mill. So if any of you would like to know more information about Yenar machines or Yenar rolls, please visit us in our booth, or you can also visit us in our factory. This is our factory. We are producing many machines every year. And you can also see our assembly and production in action. And we have a large warehouse too. Okay. Çok teşekkür ederim. It means thank you very much in Turkish. Thank you.
Thank you, Lee. Thank you for keeping it brief. Thank you very much.
As promised.
Okay. Well, that brings us to a conclusion. Thank you very much for your patience and attending. I hope you've enjoyed all the presentations, even the ones that are very specific, like the last one we've heard. And we tried to focus it on sustainability, environment, and energy. And I think all the presenters attacked their topics with that in mind. We have coffee outside here. I won't take the discussion because I think that we've overrun time quite a lot. But maybe in the coffee break here, if people want to stay and just exchange a few comments, maybe a question or two. But if anybody does have a pressing question, I'd like to take it now. But if not, then can we adjourn for a coffee and continue the discussion there? But I'd like to thank all our speakers, our three keynote speakers in particular, for taking the trouble to prepare their presentations and attend today. But thank you everybody else for attending. Let's give a round of applause to our speakers. Thank you very much.